If we want to analyze the field around charges, it's going to be much the same. So in this case here, I have three charges. The 2 microcoulomb charge is the lowest, so that is the one that's going to get 4 lines. Well, 4 is 2 times 2, so it has to have 8 lines, and 6 is 3 times 2, so that's got to have 12 lines. So that's where I came up with these dashes. I spread them out equally, so I usually do like top, bottom, left, right, and then maybe like the diagonals, however you want to phrase that. But you need to make sure that the sizes of these charges are represented by the number of lines that are emanating from them. Now, it's a little bit different with these electrical charges because there could be attraction or repulsion. So I like to start with the ones in the middle. So going between the positive 2 and the negative 4, that one is kind of straightforward to me because any positive test charge is going to be repelled from the 2 and attracted to the 4. So that arrow makes sense. I'm going to leave the 2 and terminate on the negative 4. Then, going from what I say the inside out, so if I look at the inside of the 2, which I just drew an arrow from, the next one working my way outwards is either the one on the top or the bottom. But if I work from where I just drew that arrow, working outward from that point, you'll notice that I have these 2 inside arrows. And here's what I mean by that. When I connect those, you want to connect them from the inside out. So the next one further out for the 2 is the one on top, but the next one out on the negative 4 is that one that's kind of at that kind of like angle. All right, now on the 2, that last one, we generally just kind of draw out to the side. We can assume that it goes like somewhere else in the universe, but we don't know where these other charges or what else is around it, so we just draw that out. So you can see now that all of the arrows are pointing away from the 2 microcoulomb charge. However, the 2 microcoulomb charge is going to repel things away, but the negative 4 is going to pull them, so that's where these curving lines come from. There's some repulsion from the 2, but over time the negative 4 winds up attracting this positive test charge, so you get this curved line. We could do the same on the other side. Oops, too far ahead. We could draw that first arrow and show that yes, you're going to have any positive test charge placed on the left side of that positive 6 is going to be repelled, and then it's going to be attracted to the negative 4. And I'm going to do the same thing. Working from the inside out, I'm going to start adding some extra lines. So the next line on the 6 then terminates on the next line moving outward on the negative 4. I can do another for the next. Now the issue is I can't add any more arrows to the 2 or the 4 because I'll violate that whole ratio. So I have a bunch of these leftover spots for the positive 6 that probably want to go towards the negative 4 because a positive charge will be attracted to that negative 4, but I can't actually terminate them on the negative 4 because I'll mess up my ratios that I came up with in the very beginning. So all we do is we draw them showing that they want to curve in that direction. We'd like to connect them to the negative 4, but I have to just kind of terminate them in space because we don't know what else is out there yet, so we don't know where else these might wind up terminating. But we show that with what we know, they generally want to curve towards the negative 4, and this would be the diagram for the electric field around these 3 charges.